Good day everyone, I am Regina Mia A. Geralde of MLS 2H from the University of the Immaculate Conception. Today I'll be reporting to you about the parasite Onchocerca volvulus. In my report, this includes a brief history of the parasite, its epidemiology, its morphology, clinical manifestations and pathogenesis, and prevention and control of the parasite. So, let's begin. For the introduction, Onchocerca volvulus is referred to as the blinding filaria, for this can cause blindness to those who are infected. The common associated disease and condition names are river blindness because the vector of this parasite breeds on rapid flowing waters such as rivers, and onchocerciasis derived from its name. This was first described by Leuchart in 1983. It statistically affects about 40 million people, mainly in tropical Africa. Also, adult worms coil up in knots inside the skin, resulting skin nodules. Now, let us move on to the history of the parasite. On 1874, the microfilariae are discovered by John O'Neill in crow patients. By 1890, Patrick Manson observes and identifies the adult worms. By 1893, a zoologist named Rudolf Leuchart first describes the morphology of adult worms in the subcutaneous nodules through cross-section. On 1923, a Scottish parasitologist, Breda Blaine Blacklock, concluded that Onchocerca volvulus is transmitted by sandflies. And on 1932, an ophthalmologist, Jean Hizet, describes the link between microfilariae and blindness among her patients in Belgian Congo. For the epidemiology of the parasite, this is mostly found in countries with tropical climates, distributed primarily in equatorial Africa and Central America, and is non-periodic because the specimen of choice is not blood and does not require a specific time of the day for the microfilariae to be collected and examined. Here in the blue areas of the map, this is primarily endemic in Africa and South America, particularly in East Africa, Zaire, Angola, some parts of Mexico, Colombia, Brazil, and some areas in Venezuela. Now, the vector of parasite is a black fly coming from the genus Similium. Here is a photo of the vector. The infection is greater among travelers, missionaries, Peace Corps, and other long-term volunteers, or are likely to have more intense or sustained exposure to black fly bites. Now, for the morphology, the microfilariae can range its size from 150 to 355 micra. It does not possess any protective membrane, which is called a sheath. Why? Because the microfilariae resides into the skin of the infected person, which is less aggressive and harsh for the microfilariae to develop, unlike other filarial parasites such as Brugia malayi and Onchocerca bancrofti. It has numerous nuclei with rounded anterior end, but not including the tip of the tail. The microfilariae resides in subcutaneous tissues. Now, let us move on to the adult worms. For the adult worms, it has a thin and wire-like appearance. A female adult worm can reach its size up to 500 micrometers in length and can produce up to 1,000 microfilariae per day. For the male adult worm, the size can range from 25 to 50 micrometers in length. The adult worm is white with transverse striation on the cuticle. The posterior end is curved. Here is a picture of an adult worm, Onchocerca volvulus. The posterior end is curved, hence the name of Onchocerca means curved tail. An adult worm can live a lifespan of up to 15 years, while the microfilariae can live up to 1 to 2 years inside the host. For the origin of onchocerciasis, from modern Latin onchocerca, from classical Greek onchos, meaning barb, cercos, meaning tail. Later, I will be presenting an up-close photo of the adult worm. As you can see, the parasite Onchocerca volvulus, along with Mansonella species, has a resemblance of a barb when it comes to its tail. Here is more picture of the adult worm stained with gemstain, and as you can see, it has numerous nuclei but does not reach onto the tip of the tail, does not possess any protective sheath. On the right side is a microfilariae taken from a patient with onchocerciasis. Now, let us move on to the life cycle of Onchocerca volvulus. The life cycle is completed in two hosts. The definitive host, which is us, the humans, and intermediate host, a gravid female Similium black fly. Recalling our past discussion, when we say of definitive host, the parasite completes its sexual development inside the host, and intermediate host, the parasite only develops its asexual cycle. Let us begin in this stage. During a blood meal, the Similium black fly introduces the L3 larvae, which is the infective stage of the parasite, onto the host via skin penetration of a wound bite. In the subcutaneous tissue, L3 larvae develops onto adult worms in subcutaneous nodules. When we say of nodules, this is a abnormal growing tissue. Why does it reside in the skin of the host? Because for two reasons. The proboscis of the vector is much smaller compared to a mosquito, which is a vector of Brugia malayi and Wucheria bancrofti. Second reason is because it produces unsheathed microfilariae and thus have to provide an environment with wherein the microfilariae can live and thrive. Later on, the female adult worm produces unsheathed microfilariae, which is the diagnostic stage of the parasite, that are typically found in skin and in lymphatics of connective tissues, but are also occasionally found in peripheral blood, urine, and sputum. According to a study, the microfilariae of Onchocerca volvulus is seen in these areas after taking diethyl carbamazine. During another blood meal of a Similium black fly, it ingests microfilariae. Later on, the microfilariae penetrate onto the black fly's midgut and migrate to the thoracic muscles and will develop into L1 larvae. After 1 to 3 weeks, the L1 larvae develops into its infective stage, the L3 larvae, which will later on migrate into the head and proboscis of the black fly, and the cycle repeats itself. For the pathogenesis and symptoms of onchocerciasis, it is chronic but non-fatal. There are no documented reports that Onchocerca volvulus can cause death. There are two manifestations of onchocerciasis, the systemic manifestation and the ocular manifestation. For the systemic manifestations, it changes the overall appearance of the skin, presence and formation of skin nodules along with rashes and hyperpigmentation. Here is a picture of a leg of an infected person. This is a nodule and we can see that there are lots of skin nodules. For the ocular manifestations, the microfilariae can be seen in the eyes during heavy infection and longevity of the microfilariae. Due to the bacterial Wolbachia in the microfilariae, this can cause itchiness and inflammation, forming ocular lesions, which can lead to total blindness. Here is a close-up picture of what river blindness is. Now, for the laboratory diagnosis, the specimen of choice is the skin, via skin snip, wherein a physician takes a skin sample from a patient for a skin snip biopsy using sclerocorneal biopsy punch, and slit lamp if there is presence of microfilariae in the eyes. In order to control and prevent onchocerciasis from happening, each should use personal protection. This includes putting insect repellent on exposed skin, wearing long sleeves and long pants during the day when black flies bite, and using of insecticides. Now, for the drug of choice for onchocerciasis is ivermectin, but this only kills microfilariae, and if you happen to have adult female worms inside your skin, chances of being infected again is high. Adult worms can be exterminated over the period of 6 months with maintenance of the drugs. For the nice to know facts, it is the second leading cause of blindness next to trachoma. Trachoma is caused by the bacterium Chlamydia trachomatis, and many bites are needed before being infected. Six snips are taken from different areas of the body with normal saline solution. Adult worm lives in the human host for about 15 years and the microfilariae for about 1 year. About 300,000 people are blind because of the parasite, and another 800,000 have visual impairment. Now for the next slide, I'll be showing to you a video presentation.
A scientist finds a nest of hungry beasts living under his skin.
I look into the microscope, and there are these funny little worms crawling around.
6 months after chimpanzee expert Geza Teleki returns home from Africa, his arm starts to itch unbearably.
The only thing I can concentrate on is the itching on my arm because it's beginning to drive me a bit crazy.
Dr. Martin Wolf is an expert in tropical medicine at the George Washington University in Washington, D.C.
When he came into my office, I immediately recognized that he had a swollen hand, arm, and upper arm. He also complained of some itching and rash.
He tells me to follow him into the next room, which is a laboratory. Before I knew what was going on, he took a sample of skin with a little device that took a snip out of the surface, and he stuck it under the microscope.
I look into the microscope, and this confirmed my suspicion.
He looks at me and says, "I think I know what you have."
I think Geza was quite surprised that a diagnosis could be made just on observation.
Dr. Wolf invites Geza to take a look for himself.
I look into the microscope, and there are these funny little worms crawling around. And he says, "Well, you've got river blindness."
River blindness, or onchocerciasis, is caused by the larvae of the Onchocerca volvulus worm. The parasitic worms live in the mouthparts of black flies that are common in Africa. When an infected fly bites a human, the parasite enters the body through the bite wound. There, the worms reproduce, generating over 1,000 larvae a day. For Geza, the news is devastating.
At this point, I'm not sure what's coming down the road. I became extremely worried I won't be able to continue the work. The main danger of having river blindness is, in fact, that you go blind.
Monsters inside me. Only on Animal Planet.
So this ends my report on Onchocerca volvulus.